All right, welcome to tonight's lesson. So in this lesson, we're discussing limits. And under limits, we discuss what it means for the limit to be said to exist, or we'll discuss the meaning of saying the limit does not exist or this limit exists. Yeah, and then we also know what it means if maybe the limit is approaching. Okay, let me just put it this way. We're going to discuss, or we're going to learn how we can analyze graphs and get the solution of limits from the graphs. All right, so let us quickly begin. Let us see what we have tonight. Okay, so this is your first question from your tutorial sheet. Yeah, so tonight we only, I think, do 2 questions. Yeah, so we'll probably just do 2 questions. That is question 1 and question 2. And then tomorrow when we meet, we'll do at least 3 or 4 questions. I want maybe by the end of this week, we can finish the whole tutorial sheet. Okay. So let's quickly begin. So if there are those that would like to join these live tutorial sessions, you can give them these lines on the screen. Let them contact me, and then see how best I'm going to help them. All right, so we have question 1 there. So question 1 says, below is the graph of f of x. For each of the following, for each of the given points, determine the value of f of a, 1, and then the other one we've been asked to determine. So the first one we're going to be finding is f of a. Then the second one we're finding is the limit of f of x when x is approaching a from the left-hand side or from the negative side. Yeah, so it depends with what you know. If they taught you that it's this, if we say, okay, let me just make it general. Let me tell you that you should understand that when we have a to the power negative and a to the power positive, these two a's, or these two things that you're seeing right now, these two symbols you're seeing here mean differently. Sometimes you might find negative, infinite, the infinite symbol, then you have a small negative there, then you also have the infinite symbol with a small positive there. Yeah, so this is sometimes what you may find in questions. So now let me just take some time to explain what this means. So if you have a small negative there, you may have the XY plane like that. If you have a small negative, it means that you are approaching this point A. You're approaching this point A from the negative side. And then if you have a positive power there, it means that you're approaching this value there, A, from the positive side. And in other books, they say from the left side, that is if you have a negative, and then from the right when you have a positive there. All right, so let us see how we find the solutions of such questions. So the first one is asking us to find f of a. Okay, so f of a, the first question we have is the value of a here is -5. So in other words, we're saying, let me just change the color. So in other words, we're trying to say we're finding f of -5. So f of -5 is going to be, so when you look at your table here, you look at a point if you have a shaded dot or if you have an open dot at that point A. So at that point A, which is -5, do we have any shaded dot at that point? Yes, when you check at -5 there, at a point where x is equal to -5, you find this shaded dot there. And on this shaded dot, you have to move straight to the right there and check the number which is there. And when you check here, we have 3. So f of -5 is simply just equal to 3. Okay. So that is how simple it is. So the answer there is +3. Then for the same -5, let us find the limit of f of x as x is approaching -5 from the negative side. So how do you find this? So we have to check the table, rather the graph here, and see the number that we're going to have as x is approaching what? -5 from the negatives. So when x is approaching -5 from the negative side, we have to follow this part here. Let me just circle it. This one here. So we're coming from the negative side, and then we're coming like this. So now, what value do we have for, what value do we have, or where does this limit converge, or where does this limit, or where is this limit turning in short? I don't know how I can put it, but let me just say, if you're approaching -5 from the, if you're approaching -5 from the negative side, you're coming like this. So when you reach -5 there, when you reach -5 there, when you're approaching -5 from the left, when you reach -5, what number do you have on top? So you have to go up there and see the number which is there. So we have 7 as the answer. So it's as simple as that. Let us see what the solution is if we are approaching x from the negative, from the positive side. So let us find the limit of f of x as x approaches what? 5 from the positive, -5 from the positive. So the answer will still be the same here, because as we are approaching -5 from the positive side, we are going to find ourselves at this point, because that's where 5 is, rather -5 is. When you're approaching this -5 from the left, when you reach -5 there, the number that is on top there will still be what? 7. So the answer here will still be what? 7. And then let us check the other question there. So the other question is says that we also have to find the limit of f of x as x approaches a. Okay. So we also have to find the limit of f of x as x approaches what? -5. So now, how do you find this limit? So this is where the trick is. I mean, this is a question which is a bit tricky in short. For you to know to say this limit as I mean, this limit of f of x as x is approaching as x is approaching a from either sides, if you want to know that this exists, you have to check the answers that you have found when it's approaching from the negative, and when when it's approaching from the negative and when it's approaching from the positive. So if these two answers are the same, then you can conclude and say, if the answers are the same, then you can make a conclusion and say this limit exists and its value is what? The same answer that you have there. So the answer is 7. So if you have different answers for the limits when this x is approaching from the negative or from the positive, if the answers are different here and there, it means that the limit doesn't exist. So you can just say the limit does not exist. But in this case, we have both answers being the same there, and hence the limit exists. We have another question, or we don't have. So we're done with -5. Let's move on to -1. So even for -1, we first start with f of -1. So f of -1, we go where -1 is. So we have -1 at that point. Then f of -1. Okay. You have a question?
Yes, I have a question.
Okay.
What is the difference between if the limit exists or if it's continuous or discontinuous? Is there a difference?
Normally, okay, let me just say there's a difference, yes. Yeah, so you only say this limit exists if it has if you only say this limit exists if the solution of that limit, or the solution of that yeah, if the solution of that limit from either sides, either from the negative or from the positive side, are giving you the same answer. What I mean is, if you have, let's say, if you've been asked to say, determine whether the limit of f of x as x approaches a exists. So how do you know that this limit exists? It's by first finding the limit of f of x when x is approaching the negative side of a, and then you also find the limit of f of x when x is approaching the positive side of a. So if you discover that this answer is equal to this answer, so if you discover that the left-hand side is equal to the right-hand side, then you can conclude that this limit exists. But if these two sides are different, you have to know to say the limit of f of x as x approaches a is does not exist. So if these two are different, you can conclude that it does not exist. But for continuity test, first of all, you have to find the limit of okay, for continuity test, you have to go through all these steps. First of all, you find this limit, you also find the other limit on the right, and then you check if they are the same. So if they are the same, it means that the limit as x is approaching a if they are the same, it means that the limit of f of x as x is approaching a exists. And when it exists, you have to also check and ensure that the limit of you also have to ensure that f of a is equal to what? The limit of f of x as x is approaching what? A. So if you discover that this is equal to that, then you conclude and say this limit, or rather this function is continuous at a point what? A. So if this function f of x is continuous at point A, it means that f of a is equal to the limit of f of x as x is approaching what? A. And the only way you can determine, or you can know whether this part exists or not, you have to find the solution of the left side and also the solution of the right side. So we're going to discuss that. I think I've seen such questions in your tutorial sheet. We're going to look at that, the piecewise functions. We're going to discuss that later on. Okay, so we move on to part B. So part B is asking us to find, first of all, we've been asked to find f of what? F of -1. So f of -1, we have to go on the graph and check where -1 is. So -1 is there. So this is where -1 is. Then when you check here, the dot that we have there is what? Is shaded. So now we just check the number that is there. So the number that is there is simply just 1. So f of -1 is simply just going to give us what? F of -1 will give us 1 as the solution. So this is what we have. And then we move on to the next one, where we have to find the limit of f of x as x is approaching the negative side of -1. So of course, this one, yeah, this one is still going to be 1. Yeah, you just follow the same steps that I was showing you. So let me just change the color of the marker so that I can, okay. So when you're approaching from the negative side, you're coming from this side, you still, when you're coming from this side, you reach -1 there. You go up, you still have +1 as the solution. You're coming from the negative side, you reach -1, you still have +1 as the solution. So that is what we have for this one and that one. Then to check whether this exists, you have to check whether the limit from the negative is equal to the limit from the positive. Okay. So that's what it means. So I'm sure even these are the same. I don't know, I'm just trying to see if there's one which is a bit different. Okay, let's look at this one, because this one is almost the same as this point there. So let me check this one. So first of all, we find what? F of 1 according to the question. So first of all, we have to find f of 1. So f of 1, we have to check if we have, okay, so f of 1, we have to check if we have a dot there, if the dot is shaded there. So the dot here is at 6. So you check this point. So f of 1 gives us what? 6. Okay, there's a question here. Someone is asking to say, is it always that the limit from the left is always going to be equal to the limit from the right? No. The answer is no. Why do I say the answer is no? Because you may have something like this. Let me give you an example of this question. Do I have any question that I can give as an example? Let me check the second question. Okay, so there's this question here. I think this is the best time to even answer this one. So I'll give an example of this point here. When you look at this point, this is the whole function here is f of x. So now when you check this function, when you're approaching this point, or when you're approaching this function f of x from the positive side of 1, so I'm trying to answer this part here. So if you're approaching this function from the positive side of 1, the solution will be what? Will be 4. Because you are coming from this side and you are approaching this function from where? From the positive side. So the answer is what? Is 4. And then if you are coming from this side, you are approaching the same function from the negative side. The answer is what? Is -3. So I'm sure you can see now that it's not always that the solutions are going to be the same. Yeah, so these others are simple and straightforward, but it's good that you've asked that question, and let me solve this same question as an example. So first of all, let us find what f of a is. So f of a, we simply just have to look at, we simply just have to look for a shaded dot there, a dot in short, which is shaded, yeah, or a bold dot which has no opening inside. I don't know how you can call it, but it's a dot which is shaded. Yeah, so we look, we try to find, or rather, let us find f of 1. So f of 1 in this case is what? F of 1 at 1 in along this line, or along this horizontal line. Along this line, this vertical line here. This one here. Do we have any dotted line? Any dot here? The one that passes through 1. If we have that dot, that's the one that you get as the solution for f of that number, which is, yeah, there. So in this case, we're finding f of what? F of 1. So if there is no dot, then you say it doesn't exist. Yeah, so for f of 1, we have, the answer is what? Is 2, because at 1 there, we have the y value there, which is what? 2. And we look for the dot that is shaded. And then from there, we also have to find f of, okay, this question is asking us to find different things. It's asking us to determine whether f of a and the limit of this. Let me just read through the question. I just started solving. For each of the given points, determine the value of f of a and the limit as this is approaching that. Okay, so f of a, we have managed to find this. But to find the limit as f of x, I mean the limit of f of x as x is approaching a, you need to find the left and the right side of this function at that given point. So in this case, we find the limit of f of x as x is approaching what? A from the negative side. And this is going to give you what? So if we're approaching a from the negative side, we're coming from this side. From the negative side, you're coming from this side, huh? And then you're approaching 1 from the negative side. The solution is going to be what? The solution is going to be, we're coming with this, we're coming with this function there. So the solution will be what? Will be at that point, which is just a 3 or -3 rather. So we have -3 as the solution there when you're coming from the left side. So -3 is the solution. So we have -3 there. And then when you're coming from the right, meaning we're finding the limit of f of x as x is approaching what? A from, oh, sorry, here I'm supposed to write 1 because we're dealing with 1. We're approaching 1 from the positive side. So when you check this same function, when you're coming from the positive side, you have, when you're coming from the positive side and then you're approaching 1, meaning we're coming with this function here. This is the function that we're coming with. And you find yourself at this point. So at this point, that's where we have 4 as a solution. So we have 4 as the solution there. So 4 is the solution. So you have -3 and 4 as answers. So now the question is asking us to find the limit of f of x as x is approaching what? A. So our A in this case we're dealing with is what? Is 1. So now we can conclude in this case that this limit does not exist because the solution that were found on the left and the solution that were found on the right are different. So that is how you know whether that limit exists or not. So if the solutions that you find on the left and on the right are the same, then you conclude that the limit exists and the solution that you have found is the answer to that limit. But if the solutions are different, then you conclude and say the limit does not exist. So in this case, we say it has no solutions, or you just say does not exist. Yeah, so that is exactly what you're supposed to do. Okay. So I don't know you guys if you have any questions. If you have any questions or you would want us to solve one of the questions from question 1 or question 2, you can simply just suggest so that we go through it quickly. But I think from what I've explained, you can manage to answer the remaining questions. But if there's one that you think maybe you want me to go through it, we can we can go through it together. All right, so seems like you don't have questions. I'm sure we can.
I have a question. Sir. I
Okay,
have a question. I'm looking at D from question 1.
okay.
So when I want to find the f of x, I think it has no point where it's meeting. So what's my conclusion there?
Question 1, which point, which one is exactly A, B, C, or D?
D.
C. Okay, let me check.
Yeah.
So we have C, that is 1, huh? And then your question is what?
My question is D. A is equal to 4.
Oh, A is equal to 4. Where is it? Okay, here. And then the what do you want me to find here?
Okay, so when I'm looking at Kylie, when I want to find the f of x, I think it doesn't have a point where it's linking like my f of x. I can't see it.
So f of x does not exist for this one. Why?
Oh,
Because
okay.
there's no dotted line in this line. We don't have any dot here like this one. We don't have anything like this one in this line. If you check, so meaning f of a does not exist. I mean, the f of a has, you can simply say, you can, if you want, you can say it has no solutions or it does not exist. Yeah, f of a does not exist. And then a, when it's I mean, the limit of f of x when it's approaching 4 from the negative side, you follow this line and you find yourself here. It will give you -2. When it's approaching from the positive side, you follow this line, it will still give you 2. And hence, this part will also, the solution for this part will also be -2, because this one is giving you -2, even this one is giving you -2, meaning the solution of this will also be -2. It means that it exists. And you can conclude that this function is continuous at -2. So if it's discontinuous, it will be like the way this one is, to have different solutions at it would have different solutions. When it's coming from the positive side, the answer is 4. When it's coming from the negative side, the answer is -2, meaning the two solutions, this one and this one, are different, meaning this one does not exist. And if this one does not exist, it means that the given function is not continuous at rather at +1. Meaning this whole function here on the graph is not continuous at +1, because this one and that one are different, and hence this one is also considered not to exist. That's what it means. Do you still have any questions? Any other questions? Okay, so I think for tonight we can just do this, and then tomorrow when we meet, I want us to start from question 3. We see how many questions we're going to cover going down. All right, so see you in the next lesson that we're going to have. And then if you have any questions, you can simply just forward them to any of these contacts on the screen. Then I'll see how best I'm going to help you. All right, see you in the next session.